morning, millions of people click the button on their kettle and push down the lever on their toaster, transforming electricity into heat. This process of energy transformation actually begins 152 million kilometers away, at the center of our solar system. From the sun to our kitchens, the energy that we use goes through an amazing journey and several transformations. Our sun is a massive ball of fuel from which light and heat energy is created. To find out more about the energy transformation in the sun, I spoke to astrophysicist Nico Creel from the Mount Stromlo Observatory.
So it's about 8.5 minutes for light from the sun to reach the Earth. The sun is a big ball of gas that is constantly being compressed, you have lots of hydrogen gas that compresses and leads to a fusion reaction.
Nuclear fusion in the sun converts chemical energy into heat and light energy. This solar heat and light provides all the energy our planet needs to survive. It is the source of energy that enables plants to grow. Through a process called photosynthesis, light energy from the sun is transformed into chemical energy. This chemical energy is stored within plants and can remain stored for millions of years. Long ago, the Illawarra region near Canberra was covered by a rainforest. Over millions of years, the remains of these rainforests turned into coal, which is mined today to access the stored chemical energy. The mined coal is transported to coal-fired power plants like this one near Newcastle. Inside the power plant, the coal is burnt inside a special room called a boiler. Burning the coal transformed the stored chemical energy into heat energy. This room is known as a boiler because it is used to boil water. Water flows through pipes around the room. The heat energy is transferred to the water, turning it into steam. It works just like a kettle boiling water over a fireplace. This steam expands and pushes through the steam turbine, which generates movement. This movement is a form of energy, known as kinetic energy. The steam turbine uses the kinetic energy to rotate large magnets. These are located inside a wire coil that goes around the magnets. The moving magnetic field causes electrons in the wire to move, which is known as electricity. So, the kinetic energy of steam is transformed into electrical energy. But some of the chemical energy is transformed into unwanted forms of energy, such as a noise and light energy. Also, some of the heat energy escapes through the boiler room walls into the atmosphere. These are known as energy losses. In reality, only about 1/3 of chemical energy from coal ends up in the electrical energy coming out of the power plant. Solar energy is also the source of energy from our weather patterns. The sun heats up the Earth's surface, which causes the air to expand, just like the air inside a hot air balloon. The expansion of the air creates movement, which we know as wind. This is an energy transformation. Heat energy is transformed into the energy of movement, which is known as kinetic energy. People have been using the kinetic energy for millennia, for a variety of reasons. Today, wind farms are a key part of our energy supply in Canberra. Wind farms, just like this one near Lake George, are crucial to Canberra's energy supply. The blades of these wind turbines are specially shaped so that they can turn easily even under light winds. In this way, the kinetic energy is transferred from the wind to the turbine, but it's inside the turbine that the energy transformation occurs. Like in the steam turbine, magnets are rotated, which causes an electrical current in a coil of wires, so the turbine transforms the kinetic energy into electrical energy, but around 10 to 20% of the kinetic energy is lost to other forms of energy, including noise and heat energy. But wind isn't the only source of energy used in Canberra. Solar farms, just like this one at Mount Majura, are Canberra's other main source of energy. To find out more about solar farms, I spoke to Dr. Lachlan Black from ANU.
Well, so you start off with sunlight, so that represents thermal radiation. And then the first step is that's absorbed by the cell. And so basically photons are absorbed by electrons in the material, and that represents a transformation of that thermal radiation into chemical energy.
Right.
And then the next step is you go from that chemical energy that's been generated to electrical energy.
More than half of light energy is lost as reflected light energy and heat energy. Obviously, solar panels cannot produce any electricity during the nighttime. However, our electricity use does not stop when the sun goes down. Because renewable energy sources are not steady, Canberra also relies on batteries to store energy.
And solar panels come on board that people have at their places, but also solar farms and wind farms. We need more ways to sort of actively manage that demand and supply.
The batteries convert electrical energy into chemical energy for storage. Then when needed, it is converted back to electrical energy. Unfortunately, this process also has some energy loss. About 10% of the energy that is needed to change the battery is lost as heat energy. From the batteries, the electrical energy is transported through our electricity grid to houses and other energy consumers. But this distribution network also has some losses. About 1 or 2% of the energy is lost. This loss is in the form of heat energy, just like a leaking heat duct in a house. So finally, the energy has made it to our kitchen. Inside the kettle, the electricity flows through a coil, which acts as a resistor. Just like a pack of students funneling through a narrow door, the electrons pile up in the resistor, which generates heat. This transforms the electrical energy into heat energy. This heat in the coil is then transferred to the water, which heats until it reaches 100 degrees. We lose about 20% of the energy to sound and also heat to the surrounding air. So that's how energy travels from the sun all the way to our kitchens and into our coffee.